Imagine a celestial body unlike anything we've ever seen, walking through a large empty room. Space at 3 times the average speed of comets in our solar system. This is not science fiction, but a mysterious visitor that entered our solar system in 2017. This unique object, called Oumuamua, was the first thing discovered in our solar system. The name means message from the first round in Hawaiian. The arrival puzzled astronomers and generated theories ranging from it being just an asteroid to an alien orbiting our neighborhood. Oumuamua is 15 million miles from Earth, about 62 times the distance from the Earth to the Moon. What surprised the researchers was the speed. As it orbits the Sun, it speeds up and defies the laws of celestial mechanics. Could it be a form of unknown radiation, or a comet emitting gas we've never seen before? In a world governed by rules and equations, Oumuamua is an unsolved equation, a planetary puzzle shaped like a rock. On October 19, 2017, the telescope in Hawaii captured a faint scan. This is no ordinary celestial body. This prototype was the first known object to visit our solar system. Unlike asteroids and comets born under the sun's influence, Oumuamua is a drifter from the depths of interstellar space. It showed that its orbit is not bound by the sun's energy, because it is a guest in our system. What sets Oumuamua apart is not only its origin, but also its unique characteristics. The shape of a long and fast-rolling cigar is unlike the environment. The scientific community has been rife with theories and debates about what Oumuamua looked like. A comet without a tail, an asteroid with a different spin, or something else. These questions have led to intense scientific research that has produced a variety of hypotheses, from the fragment of a larger celestial body to other fanciful ideas, such as alien research. The discovery of Oumuamua was a major milestone in astronomy. Just as man's first observation through the naked eye made him realize that the Earth was the center of the universe. It sheds light on the structure of the solar system and reminds us that our solar system is only a small part of a vast and unknown region. As Oumuamua moved away, becoming a shadow in the sea of the world, the desire to learn increased. In the future, it is hoped that more advanced telescopes will record information about these interstellar carriers, providing new clues about the formation and history of the universe. Analysis of Oumuamua reveals some interesting facts. Originally classified as comets, comets do not have the characteristics of a comet, such as a faint halo or a light tail. That is why it is reclassified as an asteroid. It's not just an asteroid, but a long, cigar-shaped object unlike anything we've seen before. His unique appearance led to different opinions, including that he was an alien. Scientific papers describe the physical properties of Oumuamua. They see that the object is rotating instead of rotating, which is different for asteroids and comets. It was due to a collision with another planet, but this idea is just a fantasy. The road to Oumuamua offers another trick. It entered our solar system at a different speed and traveled on a hyperbolic path, meaning it never returned. Most of the objects that are captured by the star's disintegration go into a circular orbit, but not Oumuamua. According to the scientists, the accident was caused by the fact that the boy's legs were very fast. However, no gas leaks were detected visually, adding to the mystery. The lack of visible light and the speed of the object have given rise to various theories. Each detail discovered about Oumuamua adds to the mystery, fueling more research and speculation in the scientific community. Some scientists say it's a fragment of a large fallen object, while others believe it's a new type of matter, rather than a comet or asteroid. Some say that Oumuamua is a solar system carrying radiation pressure. It is thought that the object's acceleration could bring another star, possibly from a planetary system orbiting the star. Oumuamua could be one of the first interstellar objects discovered, an object sent from another part of the galaxy. The story of Oumuamua is a space detective story where each clue deepens the mystery. Its shape is similar to what we see in the solar system. Could this unique shape have advantages for interstellar travel, such as reduced drag or increased stability? Or is it the result of an as-yet unknown catastrophic event? The track adds another layer to the mystery. The absence of a coma or a visible tail makes it impossible for the gas to affect the road. So what non-gravitational forces are at work here? Could it be influenced by dark matter or other unknown weather conditions? Theories about Oumuamua range from the true to the fantastic. Could Oumuamua be a messenger from another star system? The solar system is an interesting phenomenon and, if proven, could revolutionize our understanding of space travel and open up the possibility of glorious interstellar travel. When it comes to studying celestial objects like Oumuamua, astronomers rely on a variety of tools. Research into the shape of Oumuamua was led by a team of scientists including Jennifer Bergner, a chemist at the University of California, Berkeley, and Daryl Seligman, an astronomer at Cornell University. Their work, published in the journal Nature, is said to be the most convincing example of the behavior of Oumuamua. The team's observations, supported by NASA's Hubble and Spitzer telescopes, revealed that Oumuamua was unusually long, like a cigarette, and that it had accelerated as it left the solar system, e.g. according to ESA astronomer Mark O'Malley. This acceleration is seen in comets as they are ejected from the resulting material. However, Oumuamua did not display the visible cloud, dust plume and wind expected from a comet. The team used modeling to show that Oumuamua may have come from a liquid comet that orbited a nearby star before being ejected from the system. The high-energy rays can turn up to 30% of the comet's water ice into hydrogen, which is likely trapped in Oumuamua's ice as it drifts through interstellar space. As it approaches the Sun, the trapped hydrogen is released and the object speeds up. Seligman and Bergner's theory explains all the different aspects of Oumuamua. This suggests that Oumuamua is indeed a comet, albeit an unusual one. The lack of a visible coma or tail can be explained by the fact that the molecular hydrogen content is much lower than that ejected by normal comets, and therefore does not produce as much dust. Although Bergner and Seligman's theory is correct, it should be noted that not everyone in the scientific community believes it. Karen Meach, an astrophysicist at the University of Hawaii at Manoa, still believes the comet model could be in trouble. Oumuamua has very little dust, he says, because it doesn't have a plume or tail. Another theory, that Oumuamua may have been researching aliens, has caught the public's attention. The shape of the long cigarette and its different directions gave rise to the impression that it was artificial. The idea got stronger when Avi Loeb, an astrophysicist at Harvard, said that the protoplanetary system was a thin, flat, almost rectangular object that could be probed by an advanced universe. Loeb's theory was discussed in the media with great fanfare. However, while the alien research theory made headlines, it did not stand up to scientific criticism. First, if Oumuamua is a probe, it may be emitting some kind of radiation or signal that has yet to be detected. Second, its rotary motion does not match what is expected of a monitor designed for continuous motion or data acquisition. In addition, the path of the thing can be explained by environmental factors, as mentioned before. The theory proposed by Bergner and Seligman, which states that Proto-Earth is a hydrogen comet, explains its unique characteristics without the need for outside intervention. The idea is that Oumuamua may be a terrestrial exploration that reflects our fascination with the unknown and the possibility of knowing life beyond Earth. However, there are also caveats about the importance of rigorous scientific research. Imaginary theories, while interesting, can defy direct explanation. Although Oumuamua's unique features have puzzled astronomers, the most obvious explanation is that it resembles a comet or asteroid. The long journey through interstellar space changed its composition, forming a crust that contained most of the icy atmosphere. This theory explains its unique properties, supported by observations from NASA's Spitzer Space Telescope. The discovery of Oumuamua is important to understanding interstellar matter. This suggests that there may be billions of such objects moving through our solar system, and we are only just beginning to see them. The Large Synoptic Telescope, LSST, in Chile, will receive its first technical camera beam in December 2023, and the full survey will begin in October 2024. Once operational, LSST will detect other objects such as \n. Oumuamua has not stopped talking. Although this property has left our solar system beyond our reach, it is a symbol of our quest to understand the universe. Travel reminds us that the world is vast and full of mysteries waiting to be discovered.